Yeah, I'll be talking about draft relationships for animal-drawn tools and implements, with the idea of advancing animal comfort and productivity. So we'll go ahead to the next slide there. My name is Tim Harrigan. I'm on the faculty of Biosystems and Agricultural Engineering at Michigan State University in the U.S., where I lead an integrated research, teaching, and extension program in building sustainable agroecosystems, and much more recently, appropriate scale mechanization with considerable work in Africa. I've also been an executive board member of Tillers International for more than 20 years. And go ahead and next slide. Where we've been using spatial technologies to do a number of different things. Tillers has a draft animal training center there, and when I got involved, I found that, many of the people didn't understand the tools that were used. They weren't from a farming background. They were not accustomed to draft animals, and there was problems. There was problems in understanding how to apply the equipment, how to manage it, and how to set realistic expectations for the draft animals. And that led quite often to unruly or misbehavior, jumping the furrow, for instance, for cattle that weren't accustomed or able to plow, a number of things. So we started using these spatial technologies, global positioning system, strain gauge, rugged computers, the geographic information systems, and other information management software to gather, manage, analyze draft forces of both oxen and cattle. So next slide, please. So the objectives here then are to explain how modern technologies can improve animal comfort and productivity. And we'll be focusing on tillage and crop care. We've done a lot of different operations with draft animals, but here I'll focus on tillage and crop care. And I think the idea of focusing on how to manage implements to allow animals to work with less effort or to accomplish more work with the same effort. So really the focus, I think, is on the animals here. And what are we really asking of them? What are our expectations then? The graphic is just a picture of to give you an idea of some of the things we can do. And here we looked at the interaction of the load balance on a stone boat and the draft angle interaction to look at the impact on draft that we might expect with the draft animals. Of course, we had to use a tractor for a 0, 20, and 30-degree draft angle, but it allows us to do things that we normally cannot do, certainly just by watching what's happening. It's very difficult. Next slide. So let's start from the same place then. If we think of force and power measurement, draft is the force measured as kilograms force or pounds force required to move in the direction of travel. So with tillage implements, that's primarily resistance to soil and crop residues. But as most of you know that have done tillage operations, we often see wide variations within and between soil texture groups due to changes in soil moisture, residue cover, and other factors. On the graphic there, I think if you look here, you can see the load cell we have. This is in Burkina Faso, where we're testing some modifications to their cultivation equipment. And here's our GPS unit here and the data logger here. So we're getting both location and pull force information for this type of tool. So next, yesterday, Paul mentioned this oscillation or pulsation that is transferred from the load to the animals. And this is very interesting. This is a measurement that I made here. You can see here we've got on the horizontal axis time in seconds. So this is a snapshot of the pulling forces being transmitted to the team with an ox yoke. And these are the pulling forces. Now, they're in kind of 200-pound increments. 100 pound is equivalent to about 45 kilogram. But we're measuring two different types of towing apparatuses, I guess, a steel chain, which is quite common with an ox, and as a nylon rope, which is called the ZEP. Some of you may be familiar with that. So there really was no difference in the average draft here, both around 200 kgf. But the interesting thing is the oscillations here ranging around the average, anywhere from around 100 kgf to 300 kgf. So these are measurements taken every 5 seconds. I mean, 5 per second. So you can see that the variations are considerable. And this was just a stone boat, a flat platform on pasture ground. So this was a fairly smooth traveling load. So the question is that we're quite interested in is how does this affect animal comfort? It would seem that it could be a negative. And in fact, if you want to see, I focused on this in some work in Uganda with a small team there with oxen. And if you want to look at my YouTube channel, it's TM Harrigan, and look at draft animal power conservation farming initiatives in Uganda, you can see very clearly the magnitude, I think, of force that's delivered to the shoulders and the neck of some of these animals with some of these tools, a ripper, particularly in dry soil where we're doing a lot of shattering. So there's still a need to understand what this is. Is it always a negative? I'm not sure it's always a negative, perhaps. Let's go ahead and go to the next one. So I want to move on to some of the tillage tools. And this is a friend of mine, Dwayne Westrate, and this is his team of large Belgians. He's moldboard plowing here. Moldboard plowing, you'll see when I describe the size of the equipment, is how he conditioned his draft animals for pulling competitions. So it was a 35 centimeter width of cut. We're here. Well, it's a general purpose plow, and it's got a joiner here, but a 35 centimeter width of cut, 20 centimeter depth. The speed was 1 kilometer per hour, and it was a sandy loam soil. The plow draft here was pretty substantial, 522 pound force, 237 kgf. It's a good workout for this team. But plow draft, for teaching purposes, is fairly predictable. If we look at the cross-sectional area of what is being cut, and here the cross-section area is 35 centimeters by 20 centimeters, which is 700 square centimeters, and we look at the actual measured draft, 237 kgf divided by 700 centimeters squared, we can see that we're at about 5 pounds force per square inch of cross-sectional area, or 0.35 kg force per centimeter square. Now these are fairly easy to replicate given decent conditions, but I think I saw, it looked to me like in Yelmer's field, where he may look at this and say, boy, that's pretty low draft for my field. I've got a silty clay or a clay loam, and the draft easily can be twice what we measured here. So similar tools can have very different response as the conditions change. More typical in our area would be 25 centimeter width of cut, 15 centimeter depth, about 360 or 164 kgf. So, if we can convey this to new Teamsters, it'll help them start to analyze loads and be able to establish realistic expectations for themselves, but also realistic expectations for the tools. Next slide, please. Take another quick look at moldboard plow in Burkina Faso. Here, they've got these much smaller draft animals. They're oxen. Even there, a large animal would be maybe 400 kilograms. So they clearly cannot pull the type of tool that my friend Dwayne was pulling. Typical for them would be 20 centimeter width of cut, more of a 15 centimeter depth. Average force that we measured here was 93 kgf and about 4.3 pounds per square inch of cross-sectional area, just for reference, where it was 5 in our soil. This is more of a coarse textured soil, and it gives you an idea of what we're dealing with in some of these different areas with different types and smaller animals. We were interested in reducing draft and also getting away from the moldboard plow because moldboard plow is probably one of the things that causes more carbon to be released. It oxygenates the soil, warms the soil, and causes carbon release. So for soil health purposes, we are interested in what can we do to get away from intensive tillage, intensive soil disturbance. So we're interested in this ripper, inline ripper, where we're not doing full width deep tillage. We're doing in row. So we're opening up an area with a point, a ripper point here, running at about 12 to 15 centimeters. Then a rolling basket we put here to firm the seed bed so we could plant directly into that. The average draft here was 43 kgf. So we cut the draft about in half with that, which is good. And I think we encourage these well, let's go to the next slide and we'll continue with the cultivation. So one of the systems changes, if we go from moldboard full width plowing, even at a shallow depth for weed control, to an inline ripper is, well, we've just increased the complexity or the incentive for row cultivation. Their typical approach was this simple cultivator with these shovels these shovels here, you see here. This cultivator came with 5 of these shovels. The farmers didn't like it though because they were close together, and their approach to weeding is to let it grow and get it all at once rather than stay after it when the leaves were small. So the row cultivator would plug and they'd have to stop and pull weeds out, so they didn't like it. So what they did is they removed 2 shovels, they used the 3, and they were running the depth at about 7.5 to 10 centimeters, a very difficult pull. They were doing that to throw a lot of soil so that they could bury the weeds, even though many of them were not being undercut by only the 3 shovels. It was a very difficult operation. We measured the same draft with a cultivator as we did with the moldboard plow, a little bit more than 200 pounds force or 93 kgf. Our approach was to work with the local blacksmiths to train them to take a different approach. And we used these low crown, low pitch sweeps that they could build themselves because a wide selection of tools are simply not available in some of these developing countries. And the idea here was to run this at about 5 centimeters rather than much deeper. And in doing that, we were able to cut the draft from 93 kgf to 73. So we saw that we increased the width of cut by 20. And in doing so, we decreased the draft by 22%. And in doing so, we got better weed control, greater cultivator stability, and a cultivator that was easier to use. So, I think there's different approaches. In the US, we call this type of a sweep, a beet sweep. They're used in our sugar beet fields quite often and others. So different tools can give very different soil action. And if we think about tillage, draft is pretty much directly proportional to the amount of soil you're cutting, breaking, lifting, and moving. So if you can cut the depth in half, it's a pretty good chance you're going to cut the draft in half as well. So we encourage folks to think carefully about what are their tillage objectives. Let's go to the next one, please. We wanted to look at mapping pulling forces of drafts. So we had the spatial technology tools. We knew where we were in the field because we carried a GPS with us. We knew what the pulling forces were at that location because we had a pull meter. And we went ahead and were gathering that information with this single gang disc. It was a 18-degree gang angle. The mass of the disc was 228 kg. The rider was 65. So the total mass of the disc was 293 kg. Let's go ahead and move it ahead. So we were doing 2 operations on a fairly large area. We used 3 horses with this. We were also interested to know if we wanted to be more aggressive with that disc for some reason, what would be the effect of adding additional weight? So we added 71 kg. I think you can see we put these concrete blocks here just to add additional weight. And then the mass of the disc became 364 kg versus 293. And then again, we've got our GPS, we had our load cell, we're measuring draft as we went across the field. I think probably at least one measurement per second. So let's go ahead then and take a look at the map that we created. So with the GIS, the Geographic Information System, because we have location and we have force, we can map those and make them clearly available. So what you see here, for instance, the green includes all draft measurements between 350 and 450 kg. So it's a 100-pound increment, 45 kg increment. So this here was the light draft side of the field before we added weights. You can see that most of the field was from 350 including up to almost 550 pounds force. Clearly, there were areas of this field that were more difficult to disc for the animals than others. This was where we added the weight, and you can see that on the east side of the field with the light disc, the forces were 195 kgf. On the west side, where we added the weight, 250 kgf. The average draft with the disc, quite often you can estimate it fairly clearly just by mass. Well, gang angle comes into play too, but it's usually about 67% or 2/3 of the mass of the disc actually gets transferred to the towing chain and then to the animals themselves. So my question always is then, does deeper tillage improve the seedbed? Because we are now asking, it's quite visible that we are asking considerable more effort from our animals. And as I looked at this field after it was done, to me, it was no. By looking at this field, I could not tell, if I didn't know, which side was running a deeper disc, which side was not. So I think we have to encourage people to think, what are your tillage objectives? And do you need to till deep? Because when you till deep, you're asking more of your animals, particularly if they're not ready for this level of work, if the equipment is not feeling well for them or not fitting well, they may begin to act up or try and jump the furrow or just misbehave in different ways because the expectations do not match their capabilities. So to reduce draft, reduce the weight, can reduce the gang angle in some cases. But I think the idea is to manage your equipment to accomplish the objectives, but minimize what you're asking of your animals. They'll appreciate it. Next. We also looked at a spring-tooth harrow. And what interested me here in watching folks is that they would come up to this tool and hitch this tool, and they're going to practice doing some tillage, and they would grab the depth control level, and they would just run these tines into the ground as far as they could, and that was tillage. So spring-tooth harrow is a very useful tool. This was an older tool. Many of our draft farmers are using these. 23 tines, 2.3 meter width. We used 3 horses on this again because this was part of our experiment that day. This is a great tool, a seedbed tillage tool for uprooting small weeds, breaking a surface crust, leveling the seedbed, and so on. So go ahead to the next then. So we measured the pulling forces, and earlier we saw that an average draft is really a collection of pulsating forces. So here, what we did is notch 6, you can see in the yellow. This is shallow. I set this initially at what I thought was about 5 centimeters depth, which is good for this tool because that's all we need to do to break up a crust, break up small weeds, a number of things, do a little bit of leveling, freshen the seed bed. The average draft for that tool was 189 kgf. But you can see here, if we look here on the horizontal axis, what I have here is draft again grouped in 100-pound, 45 kg increments. So for instance, this includes all the draft forces, about 45%, because this is the frequency of those, that were measured between 3 and 400. These were between 4 and 500, almost 40%. So you can see what we have there with an average of 189. The green, I dropped it 2 notches, notch 4. You can see where very clearly we're asking more of our animals. 284, we jumped almost 100 kgf just by dropping this a couple inches in the soil. And then the red, this is just a small area that I did because I knew that this would be difficult. But you can see here, when I put this in almost all the way, notch 2, that, we've got here 35%, 70, so we've got 70, 65, 70% of our forces here are up 900 to almost 1,100 pounds force. A very difficult pull for people. And again, does deeper tillage improve the seedbed? And as I looked at the field, the question was no. If I didn't see it, I couldn't tell where it was 5 centimeters, where it was 7 centimeters. But I'm sure if I wanted to look at the collar of the animals and look at the effort that they put in by measuring the sweat, that I probably would have been able to guess from that. So I think the bottom line here is think about what we need to accomplish. Reduce draft. If you're accomplishing your tillage objectives, ask less if you can of your animals. They'll appreciate it. To reduce tillage depth is probably the best way to do that. So again, let's move ahead. Again, so here's the draft map. On this side, a little different view of it. And again, these are the 100-pound increments. This is the heavy draft. We're up here, oranges, yellows, and reds. So we're, largely 600 to 800 pounds force here. Yellows, blues, and greens primarily here. So we're 300 to 500 here across the field. I think what's interesting here is this was a fit field. You saw what we did with the disc. Right here, there was an additional sorghum crop and there had been some lodging and some residue gathering on the field. So we're moving this way with this harrow. And at this point, we began picking up some residue and then dragging residue and essentially plowing some soil as we did this. And you can see how the draft forces spiked when we got into heavy residue and we started dragging them along. So the lesson is keep an eye on these tools. If they start dragging a lot of residue, you're also really demanding a lot more effort from your animals. So on the west side of the field, the average was 189. On the east side of the field here, it was 284 again. And to go from tool to tool, a lot of times it's helpful to measure this on a draft per tillage tine scale. So here we're 8 kilogram force per tine. Here, 7.5 centimeters, it jumped to 12. And here, 10 centimeters, I just measured it up here in a small area, it jumped to 19 kgf per tine. So that is within the management realm of the teamster. And to be attentive, empathetic, and respectful, I think, of the draft animals, and everybody will be happy. Go again, let's move ahead. I want to visit Burkina Faso again. Again, we're at tillers and we were kind of refining this inline ripper that we used to, remember we've already cut plow draft by half with that, but they had also acquired the Shipshi Coldemulcher. It's a multifunctional tool, a rolling harrow here to break clods. We've got these S-tine, Danish tine, tillage tines, and then we've got another roller harrow here. So it's multifunctional. It's a heavier machine than we had 12 shanks. Very good tool in light crop residue, breaking soil clods, weed control, gives good consistent depth, levels and firms the soil, that type of thing. It's a very, very nice tool for that. Let's move ahead. We measured draft then. The question we had that day is, okay, we're really kind of focused here on the inline ripper. So does pre-tillage with some type of tillage tool, is that going to reduce the ripper draft? So what we did is we measured a couple things. We used the Coldemulcher. We set the initial depth at 5 centimeters, and then we tried some pre-tillage. So we went over the same location a few different times, measuring draft with each successive pass to see to what extent does pre-tillage reduce the effort that we're asking, because we're not shattering the soil, we're mixing primarily. So if we look at the inline ripper here in orange, we see that in untilled ground here, we've got then we did the untilled plus one notch, plus another notch, plus another notch. I think each notch drop was around 1 inch additional depth. So the inline ripper was here at 213 kgf, and we see that with pre-tillage we did reduce draft, not much more after the first inline or the pre-tillage here, but it reduced the draft about 13%. Now, we also focused a little bit, we wanted to learn a little bit about the cultimulture. So here in green, we ran at 5 centimeters. Then we ran again, we dropped 1 inch, but in pre-tilled soil, because this also was giving us better weed control. And then the third pass over, pre-tillage there. We saw that each time, draft actually increased about 44% from the untilled 5 centimeter to here at about 4 centimeters to 270 kgf there. In the yellow, we saw the same thing. Draft increased about 20% here. This is on our second pass, so basically it had been pre-tilled twice, but again, we're making additional passes, but we're also increasing the depth of the tool by about 1 inch each time. So it continued to increase. So we learned a little bit about that tool. Again, I want to, I have a YouTube channel that shows very clearly this. I used some very good, I think, camera work with the GoPro camera to show exactly what's happening with this tool. And if you want to look at my channel, TM Harrigan, and look at Shipshi cultimulture for draft animal tillage, and you'll get a good look at what's really happening with these tools. It's very, very instructive. So let's move on to the next one. So I want to just a summary of this cultimulture then. This is, you can see the S tines. This is the Danish points. We've got 12 points, the rolling basket. Heavier tool though, with the steel. But so when we look at the cultimulture, the draft was 33% greater than the spring tooth harrow when we measure it as kilograms per shank or tine. So it's hard to compare these tools because, well, one was 2.3 meters and the other is not. But if we look at what is the draft per shank or tine, we can kind of get closer to comparing those on an apples to apple basis. The draft range from 152 kgf at 5 centimeters to 270 at 10, so a significant increase. Pre-tillage, going back to our ripper, pre-tillage reduced draft by about 13%. Well, we saw that the benefit of pre-tillage by simultaneously increasing the depth each pass was offset. The benefit in reduced draft was offset by increasing the depth, but there may be reasons to do that. So let's go to the next one then. One last tool, field cultivator. This is a pre-tillage, and this is my friend Dwayne Westrade again. This was a tool initially made for tractors, but he's using it. He fit it so he could ride on it. It was a 16 shank tractor design, 2.4 meter, very difficult. So you can see here that he left 5 shanks out of the ground and was running with 11. We wanted to look at pre-tillage. What is the impact there? So 6 centimeter shank, 7.5 to 10 centimeter depth right in that area. The second pass was at the same depth. So what about pre-tillage in this situation? Pre-tillage at the same depth. The first pass was up here, very, very substantial. You can see the distribution of forces here with about 45% were clustered right in this 900 to 1,000 pound force increment. So the second pass, we had about a 29% reduction with pre-tillage here at the same depth, where we had, well, almost the same amount, 45, nearly 50% we're now from 6 to 700 pounds force. So a 29% reduction with pre-tillage at the same depth. So pre-tillage is something that we can use, I think, to our benefit. Remember that, well, let's go ahead and move on then. I want to be respectful of everyone's time. Now, that's all I have for tillage tools. And I just want to say a few things about harnessing system, because Paul talked about this yesterday, the need to continue thinking about this. In developing countries, farmers rely on these tools. These are the livelihood. In fact, in Burkina Faso, 70% of our farmers are doing work with hand tools. So if they have access to a draft animal, that's a real technological advance and really reduces the drudgery. But they end up asking perhaps more of their animals than they need to. And I think these innovations, such as the Maillet donkey collar here, or the high lift harness here, that's going to increase the draft because it changes the draft angle from a lower to a higher draft angle here by moving it to the animal's hips. You know, I think these are worthy animal comfort and draft reduction conservation tools that we can look at. So let's go to the conclusions then. Tillage implement draft is proportional to the volume of soil that's shattered and moved. So that, for any different tool, if you can reduce the depth, it's going to benefit your animals in terms of energy conservation. So till only as deep as needed to accomplish tillage objectives. If you can reduce the tillage depth by 1/2, reduce the implement draft by 1/2. And I think that this was referred to earlier as stubble tillage. I think I referred to it perhaps as the same thing as skim tillage. If weed control is your primary objective, shallow it up. Just undercut the weeds. Don't do a full width plow layer. In doing this, you'll improve behavior in the harness. You allow the animals to accomplish the same amount of work with less effort, and they can work longer, they can work longer with the same effort. Anyway, I think it leads to a better, improved relationship, and I think the more we understand as Teamsters, you know, the forces and the magnitude and the degree of forces that are being transferred to the animals, the more we'll be able to establish a more productive working relationship. But it's a process of conserving energy, improving animal comfort and productivity. So there's one more acknowledgement slide, and I want to acknowledge let's move ahead one here. Okay, I just have an acknowledgement there of my friends at Tillers International, and then also the USAID they had funded some of the work in Burkina Faso that I referred to. And that's it. I know that I'm crowding my time limit here, but maybe we have time for a question or two if there are any.